Hello everyone, I am Hasban Mahmood, student of National University of Sciences and Technology, Pakistan, and I am here to brief you about my project, which is memory optimization using FPGA-based motion detection. Well, my team comprises of myself and Jamal Ahmed, and like most of the participants sitting out there, we are also participants of Digilent Design Contest 2011. But unfortunately, due to visa issues, we couldn't make it to Beijing. Nevertheless, we are here to present our project virtually. Starting with our presentation, our project aim is to implement an intelligent embedded camera using FPGA that will have the capability of detecting motion and recording it. The importance of surveillance is well known today, and with their increasing popularity and demand, many modifications are made to produce a high-performance video surveillance system. One of the main concerns for such a system is storage space. Most of the CCTV cameras can record only a few days of video. With motion detection feature added, the video storage can increase by more than 10 times in some cases. Motion detection can not only be used for optimizing storage space, but has other applications too. For example, it can be used to save power by turning the air conditioners on and off, by sensing presence of people in the room. Now, in simple words, what is happening in our system? Video is acquired from the camera, digitized by the VDEC board, processed by the FPGA for any motion, and then output on the monitor. In case of any movement or motion that is there, the incoming video signal is also stored. The primary reason for preferring FPGA over other devices was its high performance and support for DSP functions. These features are necessary when dealing with video processing. Our hardware mainly comprises of VDEC board, Vertex 2 FPGA board, camera, digital video recorder, monitor. The embedded platform used for development is Xilinx ISC. ChipScope was used for testing and debugging, while MATLAB Simulink was used for real-time simulation and development of the motion detection algorithm. The programming language used is Verilog. We have divided our system into two main modules. One module deals with the interfacing of the monitor and camera with the FPGA board, while the other module deals with the development and implementation of image processing algorithm.
Hello everyone, I am Jamal Ahmed and I will explain the block diagram of video capturing system. To capture video, analog camera is used that is connected to VDEC board, which has ADC that digitize the analog signals into 4:2 YCRCB format. Now these digital signals are fed serially to Vertex to Procket, and each block of serial data is 8-bit in size, and the communication between VDEC board and FPGA kit takes place through I2C protocol. Now this 8-bit digital data is passed through data format conversion module. Now 8-bit digital data is passed to the first module of an FPGA, that is data format conversion, and its first block is of line field decoder. It extracts the timing information and control information from the video signal to detect whether the field is even or odd and the video is active or blank, and finally pass this information to the VGA timing module to generate control signals. In 422 to 444 conversion block, video data is input through the line field decoder, which is the same data that is coming from VDEC, and this block recovers the missing samples of YCRCB and convert each brightness and chroma samples in the ratio of 4, and this recovery takes place through the technique of interpolation. Then in last block of data format conversion module 444, digital data is converted into 24-bit RGB form using these set of equations. This type of formatting is required because monitor accepts only RGB signal. So the output of data format conversion module is in 24-bit interlaced form. Now this data is passed to the buffering module. Buffering module is used because of two purposes. One is deinterlacing and the other one is synchronization. First I will come to the deinterlacing. and its interlaced video is converted into non-interlaced video by using a technique of line doubling. This is done to improve the quality of the video by reading the lines twice. Thus, synchronization is performed to synchronize the data rate between the conversion module and the VGA module. Conversion module operates at 13.5 MHz while VGA module operates at 27 MHz. The synchronization is performed using dual port block ramps, and after buffering module, video data is transferred to the video DAC. In DAC, digital 24-bit RGB non-interlaced video data is converted into analog form because monitor accepts only analog RGB data. Then this video data is displayed by generating horizontal and vertical synchronous signals in VGA timing module. Now in VGA module, horizontal and vertical synchronous signals are generated using these resolution specifications. Video is displayed using 720 by 576 resolution at 50 Hz refresh rate. As you can see the blanking and active region in this picture, the area in which penguins are present is my active region and the rest is the blank one. So finally the video is captured successfully, and for image processing part I will call microped husband nodes.
The image processing module is divided into 4 main modules: color space conversion, background generation, segmentation and detection. In color space conversion module, we are converting the incoming RGB signal to grayscale. The reason for this conversion is that grayscale takes less space. Other than that, the processing becomes much faster. There are various ways by which we can perform motion detection using image processing. All of them are based on comparing of the current video frame with one from the previous frames or with something that we will call background. This background has to be stored for some time before it is subtracted from the current frame. If the result of the subtraction yields 0, it means that no motion occurred and the current and background are same. In case of any motion, the output of the subtraction will give some value. System implementation on FPGA demands special attention relating to memory consumption and timing issues. Over here, the concept is same as described before, but due to internal memory limitations, the incoming video signal will be compressed before any further processing. In order to detect motion, it is not necessary to compare each and every pixel of the current frame with the background frame. Thus, limited number of pixels is stored in the block RAM of Vertex 2 Pro. The background and the current frames are stored in two different block RAMs. The data in the two block RAMs is then subtracted and processed for any motion. If any movement or motion occurs, then an enable signal is generated which triggers the digital video recorder for storage. Our risk analysis includes unavailability of a high-performance FPGA board in Pakistan and producing a synthesizable code in given time. This motion detection system can be implemented and enhanced in a number of ways. It has a lot of future enhancements and possibilities. Examples of few are object tracking, network of CCTV systems, targeting systems, and many others. In the end, I would like to thank Digilent for letting us participate in the competition. I wish all the best to my Chinese friends and hope they like our system. Thank you very much and goodbye.